Okay, so now we're going to look at synthetic division of polynomials. Synthetic division of polynomials is a shortcut to long division of polynomials. However, you can't always use it, otherwise we would just do synthetic division instead of long division because it's much easier and a little bit more fun. Definitely less tedious. So when can we use it, when can we not use it? Well, we can use synthetic division of polynomials when the divisor is of the form x minus k. So what does that mean? Well, that means just x plus or minus a number. But the coefficient on x has to be 1. And the degree has to be 1 as well. So, x plus 3, x minus 5, both of those are good. But if I had 2x minus 5, that doesn't work. Or if I had x squared plus 3, have to do long division. 2x minus 5, I have to do long division. Now, you could argue with the 2x minus 5, okay, you actually can do synthetic division, but you have to be really careful. So in order to avoid that carefulness, let's just say long division. Alright, so what do we do with synthetic division? So in this case, I have x minus 2 as my divisor. Therefore, I can do synthetic division. How do I do this? You may or may not remember. You probably remember that at least you liked synthetic division way more than you like long division. First thing I do, take the divisor, take the divisor, set it equal to 0, and solve for x. So I get x equals 2. What do I do with that? I put that in the corner. Nobody puts baby in the corner, but you put the number from the divisor in the corner. Now, we take all of the coefficients from the dividend. Just like with long division, if you are missing degree terms, so in this case, the degree of the dividend is 4th degree. So cube, squared, first degree, and then constant, I need to have a placeholder for all of those. So the leading coefficient, or the coefficient on the 4th degree, is 1, so I'm going to write a 1. I have no cube term, so I'm going to put a 0 there for a placeholder. Then I have negative 3, then I have 0 for the x, and then I have 1 for the constant. And I'm going to draw a line a little bit below that, giving myself space, because I'm going to use this space in here, so I want to leave that there. Okay, now, the best part about synthetic division is that you don't ever actually divide anything. All you do is you add vertically, and you multiply diagonally by the value k. So you're going to start with adding. So I'm going to add 1. There's nothing below the 1, so 1 plus 0 is 1. Now I multiply. 2 times 1 is 2. Now I add. 0 plus 2 is 2. Now I multiply. 2 times 2 is 4. Now I add. Negative 3 plus 4 is 1. Now I multiply. 2 times 1 is 2. Now I add. 0 plus 2 is 2. And now I multiply. 2 times 2 is 4. And then I add again. 1 plus 4 is 5. Great. That was a lot of fun. Now what? Bring it on. Well, I have to write my answer first. So I have all these numbers. What do those actually mean? This right here, this is going to be your remainder. The rest of the numbers are going to be coefficients for their respective terms. How do I know where to put them? Well, since my dividend was a 4th degree polynomial, the quotient is always going to be 1 degree less. Think about the fact that you're starting with x to the 4th and you're dividing by x. So you're always going to end up with 1 degree less. So in this case, it's going to be x cubed. So I'm going to take these coefficients and I'm going to write them as a polynomial. So I'll have x cubed plus 2x squared plus 1x plus 2 plus my remainder over my divisor. And that is my answer. So this part's the quotient, and then my remainder is 5. Now, before we do another example, for fun, I want you to find f of 2 in the given function f of x equals x to the fourth minus 3x squared plus 1. So how do we do that? Well, this goes back to first semester as well as previous years of your high school math education. If I want to find f of 2, that means plug in 2 wherever there's an x, because in the function it's f of x, so now it becomes f of 2. So, if I type this into my calculator correctly, what do I get for f of 2? I get f of 2 is 5. Now, then you can already see the question creeping up that's already on your packet. Do you notice anything? So think about that. Pause the video and think if you notice anything about what we just did here versus what we just did previously, or if you just notice anything in life. Whatever. Write down your thoughts. Unpause when you're ready to discuss. Okay, so what I was hoping you would notice is that f of 2 equals 5, and the remainder was 5 when we divided by x squared minus 3x, or x to the fourth minus 3x squared plus 1. That's not a coincidence. So what we want to recognize is that in general, when we're doing synthetic division, f of k, if f is the dividend, or f of x is the dividend, if I plug in k to that function, that will be the same thing I get when I do synthetic division by the value k. That will be my remainder. Again, why do I really care? Well, this can be kind of helpful because when I tell you that f of 2 equals 5, what does that actually mean? Well, that means that I have some point 2, 5 on my graph, if I was to graph this function. And remember, that's what this is leading to, is actually helping us with understanding things about polynomial functions. And so I get that same information that in general I have some point kr. So if r comes out to be 0, then I know k was a 0 of the function, or an x-intercept. That's how this is going to be useful. Okay, so now, moving on to another example. Given x plus 3 is a factor of f of x equals 5x cubed plus 18x squared plus 7x minus 6, find all of the zeros. One thing to note, I'm going to emphasize this again and again and again, but pay attention to what is the question asking you to do. It's saying find all of the zeros. Now, we're going to use synthetic division to help us do that, but we still are going to have to do a little bit more work after the synthetic division. Now, why are we going to use synthetic division? How is that going to help? Well, I'm telling you that x plus 3 is a factor. So, if I use x plus 3 as my divisor, then once I divide f of x by x plus 3, I should end up with a quadratic equation that I would be able to solve to find the remaining zeros. So, let's go ahead and do that. I'm going to say x plus 3 equals 0, so x equals negative 3. Now, negative 3 goes in the corner. Another thing that I want to point out about the negative 3, this is a 0. So, since x plus 3 is a factor of this, x equals negative 3 has to be a 0. Now, if it's not, then that means that I lied to you, which is always possible, but you're going to want to err on the side of I'm probably telling you the truth. Now we'll continue to set up the synthetic division. We have 5, 18, 7, and negative 6. Give some space, draw my line. Now, I'm going to let you do the synthetic division on your own, but again, I want to talk about something. If x plus 3 is a factor, what should I get as a remainder? Think about it. We just talked about it on the previous slide. How does the remainder relate to this value? Well, it's the y value. If this is the x value on this function, it should be 0 if x plus 3 is a factor. So again, if you do not get 0 as a remainder, that either means you did something wrong, or I lied to you. In this case, both scenarios might be equally likely. However, hopefully you get 0 as a remainder. So, pause the video, do the synthetic division, find the remaining zeros then, unpause when you're ready to check your work or you get confused. Okay, so our final answer should be x equals 2/5, x equals -1, and x equals -3 are the zeros to the function. How do we get that? Okay, well we set up the synthetic division, add vertically, 5 plus nothing is 5, multiply diagonally, -3 times 5 is -15, 18 plus -15 is 3, -3 times 3 is -9, 7 plus -9 is -2, -3 times -2 is +6, -6 plus 6 is 0. Fantastic. So, I did this correctly and I was not lied to. I got a remainder of 0. Now, my quotient is q of x equals 5x squared plus 3x minus 2. But that's not the answer to the problem because, again, what did the problem ask us for? It asked us for all of these zeros. So find the zeros. Set the quotient equal to 0. This conveniently factors into 5x minus 2 and x plus 1. Set each of those equal to 0, and I get the remaining zeros of x equals 2/5 and x equals -1. Also, don't forget about x equals -3 is a 0. That is part of your answer. You will lose points on a test or a quiz if you don't write all of the zeros, if that's what the question asks for. Okay, so another thing to point out, because this is going to be a technique that we're going to be using quite often, is one really nice thing about synthetic division, or long division, but mainly synthetic division, is the fact that you are reducing the polynomial each time by 1 degree. So anytime you get down to a quadratic, you can solve this. In this case, it was convenient and it factored, but even if it didn't factor, we still know how to find the zeros of any quadratic, because we can always use the quadratic formula or complete the square. So you want to keep that in mind. Okay, so synthetic division only if the divisor is the form x minus k, which means x plus or minus a number. We add vertically and we multiply diagonally. Also, don't forget, f of k equals r when f is the dividend.